Hi everybody, welcome back again. In this video, I'm not so much giving you notes as I'm giving you a little bit of review and a little bit further explanation. After looking at some of the responses on volume worksheet 1 and volume worksheet 2, I wanted to go over a few things. The first thing we're going to look at really is over here at the volume of a cube. When you're working with the volume of a cube, it has not changed from when you were in math class. You're going to take length times width times height. Now, most people would probably label length, width, height, but it doesn't matter whenever you go to do the multiplication. You can multiply it any way you want and you'll get the same answer. For example, 5 times 2 equals 10, 2 times 5 equals 10. So it doesn't matter which way you multiply this. The biggest thing is whenever you go to plug in your, or you go to write down your answer, you need to make sure that you have the correct units and that you write it properly. In this example, when you take length times width times height, you get 8 centimeters times 8 centimeters times 8 centimeters. There are no decimals here, so you don't need to add the decimals in. You just come up with this whole number of 512, then you need to add the correct unit. Centimeters cubed would be the correct unit, and it's cubed because of centimeters times centimeters times centimeters. Now, in the Google Forms that you have been using, you can't write cubed. So what you're going to write is centimeters 3. And that was in the directions for the sections. So you're just going to write centimeter 3. That'll let me know that you mean centimeters cubed. The other thing is there are no decimals again, just like I said earlier. So 512.00 would be wrong. You don't need to add the decimals. You just need to make sure you have the correct number and the units. So that's all there is for volume of a cube. We're going to move over here to these graduated cylinders now. When you read a graduated cylinder, the first thing you're going to have to do, other than pouring the liquid in, is see how much each tick mark goes up by. The one on the left here, I'm just going to start here at 5, and then you have to figure out how many. 5, 6, 7, 8, 9, 10. So this one goes up by 1 each time. This one goes up by 1 each time. Go over to the one on the right. We're going to start at 10 here, and we go 10, 11, 12, 13, 14, 20. Can't be 1s because it doesn't make sense. How about we go up by 2s? 10, 12, 14, 16, 18, 20. There we go. So this graduated cylinder on the right goes up by 2 each time. Now that we figured that out, we could start to read it. And that's going to make a big difference. So remember how much each one goes up by. The one on the left here, remember, in both of these, the unit will be milliliters. The one on the left, it stops right on this line here. Because it's dead on that line, the final answer is going to be 9.0 milliliters. The reason it's 9.0 is what's in between 9 and 10? Well, 9.5 you could say to be exact middle, but there's also 9.2, 9.4, 9.6, 9.7. You can guess up to 1 decimal place whenever you go up by 1s. And this is what all the graduated cylinders in my class will go up by. All the graduated cylinders, or almost all of them, will go up by 1s, but they will all have 1 decimal place. All the measurements in lab will have only 1 decimal place. Let's go over to the example to the right then. We said it goes up by 2s. So 20, 22, 24, well, it's in between 24 and 26. What's in between 24 and 26? The answer would be 25. And the correct answer is 25 milliliters. This one does not have any decimal places because you can't guess any decimal places. Again, between 9 and 10 was 9.5. Over here to the right, in between 24 and 26 is 25. You don't know exactly where 25 is because it's not shown. So when I zoom in here, this could be 25. That could be 25. That could be 25. You don't know exactly, so your guess number is one whole number. That one in between, the odd number, basically. So when you go up by twos, you can't have any decimal places in your answer. But make sure when you write it, you have correct number, the correct number of decimal places, and a unit. The unit, whenever you're reading the graduated cylinders, will always be milliliters. Whenever you go up by ones, one decimal place. When you go up by twos, no decimal places. And then the final thing is water displacement. Water displacement works very similar to whenever you're just reading a graduated cylinder. There's just extra steps added in. The first thing you got to do, though, is be able to correctly read the graduated cylinder. So let's look at this example here on the left. Whenever you're looking at the graduated cylinder on the left, you can see that it's read at 19.0 milliliters. This would be your VI. That I stands for initial. It stands for initial volume, the starting volume. Over here on the right, you have VF, which equals 29.0 milliliters. This VF, that F stands for final. And that's after you add your object. So the hardest part here is going to be reading the graduated cylinders properly. After you read them properly, you're just going to go through and do VO equals VF minus VI, where VO is the volume of your object. So just start plugging away now. 29.0 milliliters minus 19.0 milliliters equals 29 minus 19, 10.0 milliliters. Be aware that you still need to have one decimal place in your answer because there is one decimal place in each of these. Your unit will be milliliters. Now, even though this is measured in milliliters because of the volume of the liquid, you can also say that equals 10.0 centimeters cubed. Because remember, 1 milliliter equals 1 cubic centimeter. That's how we can say that that metal rod in the water there, it moves 10 milliliters of water, and it has a volume of 10 milliliters or 10 cubic centimeters because it's a solid. Hopefully this video helps you out a little bit, helps you work through a lot of these problems and get a little better at them. Thank you, everybody, and have a wonderful day.